Good morning and welcome to today's lesson. We are pushing on with Pure Mathematics 3 and we are now on page 28 under subtopic 2.5, and we want to talk about sketching the graph of y is equals to the modulus of the function of x, the modulus of the function of x, and y is equals to the function of modulus x, the function of modulus x itself. There's a difference. Here in this one, the whole function is moduled. In this one, only x is moduled. And you have met the first part before, and you are told that to sketch the graph of y is equals to sketch this graph, you need to first of all sketch the graph of y is equals to the function of x, and then you reflect any part where the function of x is less than 0. Any part where the function of x is less than 0 reflected along the x-axis, and after you have done that, you delete the parts below the x-axis. We have seen this before, because no value of y is allowed to be negative. You can see the whole thing is moduled. Now, when the whole thing is moduled, there is no value of y that is supposed to be negative. Even when originally it's supposed to be negative, then it's moduled and it is absolute. The whole thing is absolute. And you understand what absolute means. You ignore the 0 part and of course consider everything to be positive. What does that mean? If you look at the graph that is this graph, if you look at this graph and you have something to do with this, and the graph is sketched that way, this is -2, this is -1, and this is probably let's say minus, let's say 6, and this is it can be 3. If this graph is the graph of the function y is equals to the function of the modulus fx, it means therefore we should have the same kind of axis here, have -2, have -1, and have 3, and of course have the 6, and of course have the 6 there, which is -6. But the upper part, all parts that are in the positive value, they remain in the positive value. But you realize that from this particular part to the left is on the negative value. So it is this part that is reflected on the positive value. Now, between -1 and -6, we had gone to the negative value of y. This part is reflected to the positive value, and this now becomes 6. And of course, the shape maintains a reflection. It is a reflection, and you can see this is already in the positive value, so it continues to the positive value. So this is now the graph of y is equals to the function of x, and this now the graph of y is equals to the modulus of the function of x. What you need to understand is that this graph, which was y is equals to fx, has been reflected along the line, the y is equals to 0 or x-axis. And when we say reflected, it is possible that the upper part is supposed to appear on the lower part. So the word reflection is not the best to use. So of course you reflect any negative part, not all the parts. You reflect any negative part. The parts that I've highlighted, those are the parts that are going to be reflected. Of course, it gets to that part, and all those other parts we have highlighted are reflected. And I want to just briefly, because we will look at other examples, to explain how do you sketch the graph of y is equals to the function of the modulus of x. There are two steps also. Sketch the graph of y is equals to fx for all values of x equals to or greater than 0, and reflect it in the y-axis. Now, let me explain something even using this diagram here. First of all, we have, that is a 1, and we have to have a graph like that. The first step, if you want to sketch the graph of y is equals to f modulus x, first of all have the graph of y is equals to fx for all values where x is equals to or greater than 0. Reason being, x itself is moduled. When x is moduled, it means we do not consider any value of x that is negative because it's already moduled. But it is important to note that sometimes x can be negative, and that does not mean y cannot be negative. Sometimes x can be negative, but when it is moduled, then we only consider the positive values of x. After we have done that, then reflect this in the y-axis. Reflect this in the y-axis. What does that mean? This is the y-axis. That point maintains that value. This one reflection becomes here. This one reflection gets here. This one reflection, so we are going to have a graph that looks like that. And this is now the graph. The graph of y is equals to fx. But if you want to reflect this one, probably to avoid them being in the same set of axes, then this graph is now y is equals to f modulus of x, because we are reflecting all values of x along the y-axis, and this is the point, the line x is equals to 0. We can also call it y-axis. That is how we get to sketch the graph of f modulus x. Well, we will get this in examples that follow, but generally, to sketch the graph of y is equals to modulus function of x, first of all have the graph of y is equals to the function of x, and then reflect all the negative y values along the x-axis. You will be getting y is equals to modulus function x. And to sketch the graph of y is equals to the function of modulus x, first of all sketch the graph of y is equals to the function of x, and then reflect everything along the y-axis. You will now come up. The reason why we talk about reflecting along the y-axis is because we believe sometimes x can be negative, and when x is negative, of course the y's are supposed to be also having its specific values when x's are negative. But of course, you have to consider it is module to start with. All right?